part of your brain acts like a pause button that freezes your whole body. Deeply focused, our bodies can enter a literal state of suspended animation. Our limbs freeze, breathing ceases, heart rate slows. The universe constricts until there is nothing but the task at hand. If we are anything like the mice studied in a recent investigation by researchers at the University of Copenhagen in Denmark, a selection of cells in part of the brain stem called the pedunculopontine nucleus, PPN for short, could be responsible for this freeze frame effect. The discovery not only helps us map the location of tissues that contribute to the more Zen-like properties of the human mind, it could help us better understand the progress of symptoms in neurodegenerative conditions like Parkinson's disease, potentially leading to better forms of therapy. Animals like us have plenty of reasons to stop suddenly in our tracks. Fear-induced freezing, for example, gives prey a fighting chance to avoid detection. Defensive global motor arrest is a relatively well-studied function of the nervous system, with pathways traced between the lower brainstem and the amygdala or fear center, and the periaqueductal gray in the midbrain. But predators have their own reasons for playing statue, based on a need for concentration rather than fear. In fact, most animals have moments where they need to pause in a perfect freeze frame and let the world wash over them. To locate the brain cells responsible for this specific form of motor arrest, researchers used mice engineered to have special light-activated neurons in the PPN, a part of the brain already known to suppress muscle tone when stimulated. This small knot of nerve cells in the pons, a region of the brainstem implicated in conditions such as sleep paralysis, consists of three distinct classes of nerve cells known as glutamatergic, cholinergic, and GABAergic neurons, all layered in a distinct fashion. Triggering the PPN's glutamatergic neurons in rodents tends to show their movements, encouraging them to become more explorative. Curiously, not all investigations have reported the same results, with some observing the test subjects' muscles locking up together. By restricting the activation of glutamatergic neurons to specific regions of the PPN, the scientists behind this latest experiment pinpointed the small clusters of neurons that cause the mice to pause, freeze, and then resume their previous activity. This pause and play pattern is very unique. It is unlike anything we have seen before, says the study lead author, neuroscientist Haizea Goni-Ero. It does not resemble other forms of movement or motor arrest we or other researchers have studied, and there the movement does not necessarily start where it stopped, but may start over with a new pattern. We humans also have a PPN, so it's not a huge stretch to assume that it also contains a small population of nerve cells that coordinate our muscles into a stop and think moment, giving us the mental space to remember where we put our keys or to allow us to line up that perfect putt in golf. Of course, as with any piece of neurological wiring, short circuits can arise in the PPN's functioning. In light of this finding, it's highly possible that the slowed or arrested movements in individuals with Parkinson's could be the result of overactivation of these specific nerves. Therefore, the study, which primarily has focused on the fundamental mechanisms that control movement in the nervous system, may eventually help us to understand the cause of some of the motor symptoms in Parkinson's disease, says neurologist Ole Kien. And this was published in Nature Neuroscience. It's on Science Alert by Mike McRae. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.